Hey, my name's Annan. I'm the software lead for this upcoming year, and I'm here to talk to you a little bit about what robot operating system is, how we sort of use robot operating system, or ROS as we call it, to share a bunch of data around all the different parts of our robot, talk about some commands that we use a lot to sort of interface with ROS, and talk about a few tools that we regularly use as part of the ROS framework. So first off, what is ROS? ROS is sort of the core architecture that we use on our robot. It is the core thing that runs. It is the thing that brings all the information from our nodes. I'll avoid the word nodes there, but it's the thing that brings all our sensors, all our everything, all the data from those all together, puts it through a bunch of code to figure out what our robot should do from that data, and then translates that into actual action, like moving thrusters, stuff like that. So how does that actually work, though? So ROS is what's called a messaging service. What this means is that it is a service that lets you put a bunch of nodes, as they're called, which you can see in this picture that's up on the screen, lets you put a bunch of nodes together, run a bunch of nodes at the same time, and share data in between them. So what we can do is we can use that whole framework to take data from our sensors, feed it into nodes that process that data, and then feed that processed data into other nodes, and then from those nodes into other nodes, and then into nodes that control stuff like thrusters and stuff like that. So the important thing to note about ROS is that it is all asynchronous, and all callback based, both of which are terms that I'll explain right now. So what we mean by asynchronous is we mean all of these nodes are all kind of running at the same time. They're not running at the exact same split second or anything like that. That's processor level. That's not something we need to worry about. But all of these are kind of simultaneously running, waiting until they get input, doing something with that input, and then outputting that input, a process which I'll talk about later, and callback based. What this means is that all of these nodes are kind of just waiting for something to be input to them. I'll talk about a little bit more about what this means later as part of topics, but kind of what's going on here, specifically with the depth processor, it's waiting until it gets data in. Whenever it gets that data, it executes a callback function on that data, which does whatever it needs to with that data, does whatever processing it needs to, and then actually outputs that data somewhere. A procedure which I'll talk about more in a minute. Make that not a minute, make that now. So we are on to topics, which in short is kind of what these data streams or these ways to transfer information in between nodes is in the ROS framework. So there are two things you can do in relation to a topic. You can either publish to it or you can subscribe to it. If a node subscribes to a topic, that means that it is waiting for data on that topic to show up. It's waiting for something to be put on that topic. If a node subscribes to a topic, for example here, the depth processor node is subscribing to the depth raw topic, waiting for something to be put on that topic. And then whenever something's put on that topic, it'll do something with it. It'll say, hey, something was put on that topic. Let me execute this callback function that I have, which will do all that sort of processing. And then what happens when it's done with that is it's going to do something called publishing, which is sort of the converse to subscribing. Publishing is what happens whenever, instead of taking data from a topic, you're putting data onto a topic. In our depth processor example, what's happening is it is subscribing to the depth raw topic, waiting until something is published on here, processing it, and then it is publishing to the state depth topic, which other nodes like the alignment controller and depth controller, stuff like that, subscribe to and actually do the same sort of procedure with that. So what's kind of happening with all of these is that these are all accepting in some topics, executing callback topics whenever those, not executing callback functions whenever those topics are subscribed to, and then publishing afterward to whenever we'd have done our actual processing, which lets all our other nodes actually get access to that information. So this whole system of topics within ROS lets us separate our system into all of these different nodes. each of which only does a little bit of processing on the data or changes the data a little bit. But it allows us to kind of pull all these together, use this kind of atomic structure where there's just small topics that we actually like publish to and subscribe to, and lets us sort of build them up from a little bit of code in each one to an overall subsystem or an overall system that does a whole lot. So that's topic. Subscribing is whenever you're waiting for something to be published onto there, and then publishing is whenever you're actually done with it. You actually put it back onto the topic, and then there are other things that listen to that topic, and it sort of all goes through here. So as part of ROS, there's some not topics. There are a bunch of commands that you should be familiar with. There's not really a bunch. We only use maybe like 5 or 6 of them regularly. So what I'm going to do is I'm going to pull up a terminal here. Shortcut for that on Linux is Control-Alt-T, which you're going to want to get used to. The first one, important one, would be ROS core. What this does is this just starts up the basic ROS server. What ROS does is it runs one server. Like if we put it on the robot, it's going to run one server that runs all of our different nodes at once, effectively at once. But what ROS core does is it just runs that server. It doesn't actually load any of the nodes onto it. This is the complete base server that is sort of the base of how we load nodes into this. So that's ROS core. The next command that I'll be talking about is ROS launch, which is sort of how we specifically go about loading our nodes into ROS core. So the syntax for this is ROS launch, and then it's going to be the name of a package. Like the packages in our system are like Riptide Bringup, Riptide Controllers, Riptide Vision, stuff like that that's inside source. So I'll pick a package name. For the purposes of this, I'm going to launch the simulator, so this would be Riptide Bringup. Bringup as in like that's how we bring up all our sensors, is how we're actually going to run the robot. And then if I tab complete this, which also tab completing, like if you tab complete Riptide Bringup, that is a great way to see if your system's working or that your terminals are sourcing correctly and stuff like that. But if I tab complete right here, I'll see that there are 2 launch files that are sort of waiting, like to be selected kind of. Launch files are like a ROS specific file. They're very similar to XML. And they basically just define all the nodes we want to launch, parameters if we want to use them. There's a pretty extensive system. You can look it up if you want more detail. But what this is going to do, I'm going to launch a simulation, the simulation launch file. What this is going to do, we're going to see a whole bunch of output get spit out at us here. This is going to launch all of these nodes. There's going to be a whole lot of stuff going on. And then it's going to load. Sorry if this is a little laggy. My laptop is not the best. But what just happened is ROS launch sort of implicitly launches ROS core for you, first thing. And then what it does is, as dictated in like whatever launch file you're launching from, it's going to actually load all those separate nodes in. So what's going on here is that the robot is actually in here. Our entire robot, our entire code base is running right now. It doesn't look like there's a lot of movement going on because it's a little involved how we're actually getting the robot to move, which is not really in context of this tutorial. But all the different nodes are running right now. They're passing data in between them. They're publishing and subscribing to topics. There's a whole lot of stuff going on. But ROS launch is basically always how we're going to be launching the entire robot and how we launch most stuff. We basically never, there are ways to do it, but we basically never launch single nodes at the same time. That's kind of just not how ROS works. ROS is built on being able to take a bunch of different subsystems and pass the data in between them and have them all work together. So that's ROS launch. While I have our system kind of pulled up here, I'm going to explain a separate topic called, not a separate topic, a separate command called ROS topic. Now, I'm going to be keeping the simulator up in a separate terminal because the topics we're going to be looking at, they're only like active, they're only running whenever the actual robot system is running. So the ROS topic command itself doesn't do anything. It's just going to say like, what do you want to do? But this right here is all the commands that you can execute. The ones here that we use, I'll start with ROS topic list. What this is going to do is it's going to print out every single topic that is on the robot right now. Not all of these are like being actively published to or anything like that. We don't actually use all of these. We probably have to do some maintenance on that end. But these are the exact topic names. Like the things that were, the arrows that were in between the nodes, this is sort of the equivalent of those. And a lot of these correspond exactly to that. I think we need to update the image a little bit, probably, because we make changes pretty frequently. But these are all the topics themselves. So ROS topic list, lists out everything. ROS topic info, and then a topic name. Say we want to see what's going through, what data is happening in IMU data. So what we'll do is /puddles/IMU/data. So what info does is it just prints out what is, so it prints out three things. I'm kind of confused right now because I thought I ran a different command, but I ran ROS topic info. What ROS topic info does is it takes this topic, it says what message type it is. Messages are basically, I don't know if it's going to be covered in a different tutorial, but messages are basically, they basically just are the format that we pass data around. Like we might have a message that's just like a vector 3 where you have an XYZ coordinate. We might have one that's just a depth. In this case, it's an IMU message, which I don't think I currently have pulled up. No, I can. I can go into a Riptide messages. If we look through here, this is all of the custom messages that we use. So, for example, the depth message, it just has a header, which is something that every single message has to have. It's just like a timestamp and stuff like that. But this message also has a depth and a variance with it, which are things specific to our depth sensor, stuff like that. Like our DVL has a time, whatever the heck all of these are. It just has a whole lot of stuff. A message is basically just like a package to send a bunch of related data in. And it makes it so we're not just passing single bits of data around everywhere. So back to our terminal. Publishers, it tells you which, what publishes to that topic. I think that this is a weird thing going on with Gazebo, which is a simulator. A lot of the times this will just be like a specific node. Like you see the subscribers down here, this is a specific node. This is our AKF localization node, which if you're curious about, you can ask about. But this will just say which nodes are publishing and subscribing to that topic. With ROS topic, there's like the ROS topic command, there's probably only one other important command. ROS topic echo. I'll cover Hertz as well, but ROS topic echo. I'm just going to see what we have available again. We have, so say we want to see what that DVL message, where's the DVL? It wasn't the DVL, it was the IMU. Oh no, it is. We'll do the DVL. Say we want to see what's actually being published to this topic right now. So puddles DVL state. What this is going to do is this is going to spit out, I didn't pick a very good message, but what this command does, I'm going to pick a different message. What did I use before? I used puddles IMU data. So what I'm going to do is I'm going to say ROS topic echo, all this. There we go. So what this is showing us right now is this is going to print out every single time that topic is published to. And it's going to print out the exact message that was being published. It's kind of going, I don't know why it's blacking out here. It's because I'm on the top of the terminal or something, and this just publishes so quick. It's being published so frequently too. But we can see here, this is the entire message details. This is the actual numbers that are being published inside that message. So this is sort of the main way to look at what's going on inside of a message. There's also a way to do that from within RQT, which we'll mention later, but this is sort of the main way to do it. And ROS topic Hertz, I'll just do the same one. Speaking of how quickly something's being published to, ROS topic Hertz just tells you the frequency that something is being, it like samples the topic and tells you how much it's being published to. So, Fresh mentioned it earlier, because there's a variable amount of computation that has to happen, like sometimes we have a lot of data to process, sometimes we don't have that much data to process, it's not always going to be an exact frequency that like a topic is published to. Everything kind of just runs as fast as it can. and if there's too much workload for our system, if it has to like miss some messages or something, it'll just get rid of the oldest ones. So we're not just operating off of second-old data the entire time. It'll get rid of the oldest ones. But in context of our system, that basically, not even basically, it never happens. And we can see here, it looks like this publisher is configured to run at 50 hertz. And that's about all there is to ROS topic hertz. And then the last command I want to go over, I'm going to shut this down because it's not really useful to us anymore. You can just shut this down with Control-C. The simulator takes a while to shut down for reasons that we still have to figure out. Well, we kind of know, but whatever. Out of context, out of scope. So last one is going to be ROS run. ROS run is what we use to run. We don't really use it for a ton, but it's basically how you would go about running a single node. What we usually use it for is just to launch a few ROS tools, which is what I'm going to go into right now. So the first tool I kind of want to show off is RQT GUI. So how you launch that's going to be ROS launch, RQT GUI, RQT GUI. What's going on here is not ROS launch, ROS run. So what's going on here is the first one is the package name. The package name is just called RQT GUI, and the node name itself is called RQT GUI as well. So what's going to happen when we launch this? It's going to launch RQT. This is a fresh install, so I don't really have much set up. But the real power of, I probably should have just left the simulator out, but it's okay. Lags my system up anyway. There's some important things you can do from in here that we use. So what we do here, some interesting plugins that we end up using a lot that you'll want to check out. Dynamic reconfigure. It's complaining because there's not a ROS core running right now. Like I shut the simulator down. So I'll just talk through these. Dynamic reconfigure is basically how we go about changing values inside our system. Like, because if you want to, a lot of times if you have to change constants in your code or something, we'd have to go about fully rebuilding it every time or something. Dynamic reconfigure is a way to set up values so that you can do that during runtime. So you'll want to check out, figure out how that works. Node graph is what I was showing off from the GitHub page earlier. That's how we generated this big thing. This is from our system. We also have, no, that's really important. Bag is related to ROS bags, which you're probably going to want to look up as well. No, that's important. Move it, we kind of are starting to use, but just stay tuned for that. It's not important right now. And the topics. Topics are pretty important. The message publisher is how we're going to go up manually publishing the topics. For stuff like the control system, if you're trying to test it out on one of the command topics, you can just publish something there. It'll figure out. I'm going to start up the simulator actually because I'm going to start up the simulator again, which I guess will be a good tutorial on how to do it again. So I'm going to go right here. I'm going to run this at the same time. Save all this. Parth, you might just want to cut to what I'm about to do. I'm just going to start this from scratch, start RQT again from scratch. So I'm just going to do it from here. Let me shut down RQT, stuff like that. Go to terminal. Where the hell is my terminal? Oh, okay. Okay, so RQT GUI itself is what we use to do a lot of stuff for the robot. We use it for something called dynamic reconfigure, which I'll explain in a second. We use it to interface with topics if we need to do anything manual with them, and a lot of stuff like that. How we're going to be launching this is with ROS run, which at a low level is basically how you'd go about launching a single node. We very rarely use ROS run in context to our actual system because we have a whole lot of nodes to run, and ROS run doesn't really do that. But what we do is it's ROS run, and then the package name, which in our case is just RQT GUI, and then the node name, which is also RQT GUI. This is going to launch RQT GUI, which we use a lot for reasons I just explained. The power of RQT is that there's a lot of plugins here that are useful to us. So dynamic reconfigure is how we go about changing a lot of constants in our code during runtime. I personally haven't used this too much. We don't use it a ton, but it's useful to go through this and figure out how it works. Dynamic reconfigure is how we change values in our code during runtime. Normally, when you change constants in something like C, C++, or something like that, a lot of time you have to fully rebuild. Dynamic reconfigure is a way through ROS that you can change a lot of that stuff during runtime, which saves us a lot of time in certain circumstances. Second, what we want to talk about is the message publisher, which is not opening. Nope, it's opening. So what the message publisher lets you do is publish messages, but this is how you would do it manually as opposed to our system doing it. So if we go here, this is all of our topics. So what I'm going to do is I'm going to go to the, I'll do one of the command topics. It doesn't really matter. But how you're going to add a topic that you want to publish to, you can usually just keep this the same. This is just the message type that is usually published to that topic. You can select a frequency, and then you're going to go and add it. So what you can do with this now is you can select this. This box lets you select if you want that to currently be publishing. So if I do this, that topic is now publishing once a second. And then in here, you can go in and change all these values. If I want to change this Boolean value that's being changed, I just change it like this. You can just change this here. Doesn't really matter. I'm pretty sure that's above water. I don't know our frame of reference there. But this is how you go about doing that. If you only want to publish one, you can right-click and do publish selected once, or this is how you also remove them. So good intro to the message publisher. Next we have, well, last, I think. Yeah, we'll do ours separately later after this. The topic monitor is probably the last one. This also lets us visualize what's going on with other topics. So what we can do here is we can go in each topic and see which fields it has. This one only really has a header and something called status list, which is something from ActionLib, which is test code stuff. It's probably not a great example, but for, where's the DVL message? Something like the DVL, you can see there's a whole lot here, and it tells you which data type everything is as well. So this is probably the best way to figure out what exactly goes into a topic. Either by finding, if it's a custom message, you can find the topic like I discussed earlier, or just do it through here. So that's probably a good intro to our Qt GUI. Just to recap, we basically just use it for dynamic reconfigure and to interface with topics. Last, I'm going to be showing off something called RViz, which is kind of just how we visualize. It's short for like robot visualization or something like that. You can just launch that via RViz. Just easy command. So what you're going to do to set up RViz, you have to do a little bit of config to get it set up. So first we're going to change the frame to where's either world or ODOM, I think, to ODOM. And then what we're going to do is we're going to add a robot model or something like that. Yes, robot model. I'm going to change this. We're going to change this to puddles, if RViz would like to cooperate. RViz, no, not RViz, my God. Changes the puddles. We see that puddles' model is now in here. This isn't going to do a whole lot in and of itself, but this is going to reflect what's actually happening in the simulator with the robot. Last important thing would probably be, well, actually there's two more important things probably. If you want to see our transform tree, like our TF tree, this basically shows the frames of reference. You can zoom in and out here, but RViz isn't letting me because I think I did oh yeah, no it is. It's just lagging. But TF lets you look at all the frames of reference and which frames of reference are attached to which. You can go through the TF tree and a whole lot of stuff here. And last important thing is visualizing topics, which is a lot of what we use it for. So whenever you go to add, instead of doing that, you can do it by topic. This lets you basically visualize everything that's going on with actual things. So if we go to, say we want to view puddles /downward /image HUD, it's right here. So if I want to look at the camera view of it, I'd go like that. And I really hope this doesn't break. I think it's not just showing up because it's invalid or not being published to or something like that. Let me try one separate one. Or maybe it's just lagging. Stereo. We'll do this because I work with stereo. Okay. Which color? Maybe we'll visualize this one. So this is what the robot's actually seeing through one of its cameras. There's simulator plugins which allow the simulator to actually output cameras like this, because there's not actually a camera, it's all on the computer. But this lets you visualize. There's a bunch of different ways to visualize different topics. Like there's ways to do it for a point cloud, ways to do it if it's just like a scalar or a vector, or there's a lot of things you can do with RViz and stuff like that. So that's RViz, and that's the tutorial, the video version of the tutorial. So just to recap, we covered ROS, which is just the messaging system that lets us talk between nodes. Topics are the things that you publish to and subscribe to enable talking between those nodes. ROS core is the base ROS server. We don't usually use this itself. It's launched implicitly from ROS launch, but it's important to know what this is. ROS run is how you're going to launch a single node, but we usually just use it to launch stuff like RQT GUI. And ROS topic is how you view information like frequency, the data that's actually on them, stuff like that about ROS topics that are currently running. And then we covered RQT GUI, which lets us do stuff with dynamic reconfigure and manually publishing and subscribing to messages. And RViz, which lets us do some cool stuff like looking at our robot, the transform or TF tree from it, and visualizing topics in a bunch of different ways.